Most people are using Copilot wrong. It isn't because they're bad at prompting, and it isn't because they haven't learned the latest tricks. The problem is that they think Copilot is a tool, a feature, or maybe just a faster search engine that talks back. You open it, you ask a question, it writes a response, you copy the text and close the window, but that isn't Jarvis. In reality, that's just a smart stranger you meet fresh every morning who has no memory of what happened yesterday. Real agency isn't about writing better prompts. It starts with structure. It requires a system that actually knows who you are, how you work, and what matters to your business. You need a system that doesn't just answer. It acts, it decides, it orchestrates. That is exactly what I built. And that is what we are building together right now. Why Copilot fails at agency. Here is the core problem with how most people use Copilot. Every single time you open that chat window, you are starting from zero. You don't carry your context forward and you don't maintain any continuity between tasks. The model has no idea what you decided yesterday or why you made that choice. It doesn't know your internal processes, your team dynamics, or how you adjust your communication style for different audiences. Each conversation is an island. The result is that you have to re-explain yourself every single time. You tell it you're working on Q4 planning for the sales team, you explain the budget constraints for the 3 regions, and you list what worked or failed last year. Then you ask for a proposal. The model gives you something decent, but the output is generic. It could apply to any sales team at any company in any quarter. That doesn't happen because Copilot is stupid. It happens because Copilot has no memory of you. And that is the first architectural flaw. Context window limits might sound like a technical detail, but they are actually strategic constraints that force the system to fail. Your context window is finite. Even with a modern model offering 200,000 tokens, the space disappears faster than you think. Once you load historical decisions, past meeting notes, and communication guidelines, the window is already getting crowded. Layer in your organizational structure and previous project outcomes, and you quickly run out of room. So you start to compromise. You only load what seems most relevant in the moment, which means you spend your time editing and curating instead of working. You just hope the model guesses what actually matters. This is death by 1,000 cuts, because the model doesn't actually know your context. It is just pattern matching based on what you fed it during this specific session. The moment you need to reference a detail from 2 conversations ago, the system has no idea that the information ever existed. But here is where it gets worse. Without persistent memory, Copilot stays reactive instead of becoming proactive. You have to prompt it. You have to ask the questions. You have to be the one who remembers that a question needs to be asked in the first place. Copilot never initiates a thought. It never spots the patterns that you might have missed. It will never tell you that you're consistently underestimating timelines in resource-constrained environments based on your last 3 project retrospectives. That isn't how the tool works. The system just sits there and waits for you. The second flaw is structural. Most implementations treat the chat box as the final interface where you type and it responds. But the chat isn't the outcome. The chat is just the medium. The actual outcome you want is action. You want a decision made, an email sent, a task created, or a complex workflow triggered. Right now, Copilot drafts the content while you approve it and execute the rest manually. You copy the text, you open Outlook to send the message, and then you jump into Teams to notify your stakeholders. Finally, you open your task system to log what happened. That isn't orchestration, that is just Copilot acting as a basic assistant, which means you are still the one doing the heavy lifting. Real agency means the system handles the orchestration itself. The system plans the multi-step sequences, calls the necessary tools, and triggers the final outcomes. You stay in control, you still approve the high-stakes decisions. But the system isn't just handing you a draft for manual assembly, it is planning the action from end to end. The third flaw is organizational. Most people treat Copilot as a small feature tucked inside another system like Word, Teams, or a sidebar in Outlook. But that is completely backwards. The question isn't how you add Copilot to your workflow. The real question is how you make Copilot the platform that your entire workflow runs on top of. That is the shift. Moving from Copilot as a feature to Copilot as an OS requires a new architecture. It needs memory that lasts across sessions, and it needs the ability to reason about which action to take next. It requires structure. Without structure, Copilot is just clever. With structure, Copilot becomes truly intelligent. The difference isn't subtle. It is the gap between a tool and a system. It is the difference between asking for help with an email and having a system orchestrate an entire process while you focus on what actually matters. That is what Jarvis is, and that is what we are building next. The Jarvis model, what it actually is. Jarvis isn't a new AI model. That's the first thing you need to understand. It's not GPT-6, and it isn't some secret version of Copilot that Microsoft is hiding in a basement lab. Jarvis is architecture. It's a way of organizing Copilot so it functions as a complete system instead of just a single tool. This setup allows the AI to carry forward everything it learns. It stops being a chatbot that just responds to your prompts and starts being a system that orchestrates work on your behalf. Think of it as 4 interconnected layers stacked on top of each other. Every layer has a specific job, and each one makes the layer above it possible. The bottom layer is memory. This is where Jarvis learns who you are, but I'm not talking about your name. It learns your patterns. It understands how you make decisions, what you value, and how you prioritize your day. It knows how you talk to different people, and which frameworks you use to solve problems. It sees your team structure and remembers the details from past projects that actually matter right now. Memory isn't just a pile of old notes. Memory is instruction. It's the constitution for your entire system. In the Jarvis model, memory lives inside structured files called skill.md documents. These files don't just store what you know, they encode exactly how you work. They capture your communication style, your rules for making decisions, and your non-negotiables. They even track your risk tolerance. The system reads this memory at the start of every single session. It's like the AI is reading your personal operating manual before it takes a single action. On top of memory sits the action layer. This is what Jarvis can actually do. It's not about what the AI can write, it's about what it can execute. It can send an email, create a task, or update a spreadsheet. It can schedule meetings, file documents, and post to your team channels. It can even trigger workflows in other software. An action layer without memory is dangerous because you end up with a system that can do things without knowing when it should. It's like a loaded gun with the safety off. But when you combine memory with action, you finally get the beginning of true agency. The third layer is reasoning. This is where Jarvis decides which action to take in a given moment. Not every decision is a simple yes or no, and not every situation follows a routine. Some emails need to be escalated immediately. Some tasks require a completely different approach than the one you used yesterday. Sometimes a pattern emerges that demands you break your own rules. The reasoning layer uses Copilot to look at the context, apply your specific rules, and choose the right path forward. It's the layer that recognizes a high-priority situation from a VIP client who never complains. It knows to escalate that issue and involve a human instead of just drafting a generic reply. Reasoning without memory is just guessing, and reasoning without action is just philosophy. But when you combine reasoning, memory, and action, you get real decision-making. The fourth layer is governance. This is the part that defines what Jarvis is not allowed to do. These are your guardrails and your limits. This layer defines the AI's authority. It dictates which data the system can read, what it can change, and which decisions it can make on its own. It sets the boundaries for which systems are accessible and which ones are strictly off limits. Governance might sound like boring bureaucracy, but it's actually about survival. A system with agency that you can't control isn't a tool. It's a liability and a lawsuit waiting to happen. When you put these four layers together, you get one major result. The system operates instead of just responding. Here's the real difference. Responding means Copilot sits there and waits for you to ask it something. You give it a prompt, it gives you an answer, and then you have to decide if that answer matters before you go execute it manually. Operating means Jarvis is watching your work and understanding your context. It sees patterns you haven't noticed yet and takes action based on your rules without waiting for you to ask. You don't have to tell Copilot to draft a follow-up email for a client you're trying to close. Jarvis sees the email thread and realizes the deal has stalled. Because it knows the rhythm of your follow-ups, it drafts the email, flags it for you to look at, and sets a reminder for later. You don't have to ask Copilot to organize your priorities for the week. Jarvis reads your calendar, pulls your project notes, and notices that several deadlines are hitting at the same time. It drafts a plan, points out the conflicts, and suggests exactly how to fix them. That's the big shift. It's moving from assistance to orchestration. It's moving from help me to handle this. It's the difference between a tool you use and a system that actually works with you. Now that we know what Jarvis is, let's look at how you actually build it. The memory problem, context that persists. Memory isn't just a side feature in Jarvis, it's the entire foundation. Most people get memory wrong because they think it just means saving your chat history. They think if they dump their emails into a database so Copilot can search them, they've solved the problem. That isn't memory, that's just archiving. Real memory in this system is instructional and constitutional. Look at it this way. You have data about your work, like the emails you've sent and the meetings you've attended. That's your history. It tells Copilot what happened in the past. But you also have rules for your work. You have a way of making decisions in a specific way. You talk to different audiences. You have risks you're willing to take and others you won't touch. That's your constitution. It's operational, and it tells Copilot how to act when it runs into something new. Most people save their data, but almost nobody structures their rules. Jarvis does both. Your vault isn't just a pile of notes, it's the instruction manual for your system, it's the version of how you actually work, written down in a way the AI can follow. This is where those skill.md files come into play. A skill.md file is just a markdown document that lives in your system. It's structured with metadata, rules, and examples. It encodes a specific capability that Jarvis can use over and over again without ever needing to ask you for directions. For example, you might have a weekly planning skill. The file starts with a name and a description. It explains that the goal is to synthesize the calendar, active projects, and stakeholder updates into a prioritized list. Then come the instructions. These aren't vague prompts. They are specific steps like read the calendar and identify deadlines in the next 14 days. It tells the AI to flag resource constraints and suggest a new order if there are conflicts. You also include examples of what a good output looks like. This is vital because Jarvis needs to know what success looks like to you, not just what a generic AI thinks is good. Finally, you add constraints. You tell the skill what it should never do. Maybe it's never allowed to commit to decisions that need board approval, or it's never allowed to schedule meetings on Friday afternoons. Once that file is in your vault, Jarvis reads it. Now, the system doesn't just know what weekly planning is, it knows exactly how you do it. The difference is massive. You only have to write that file once, but Jarvis will use it every single week for years. As your process gets better, you update the file and Jarvis adapts instantly. This is how your system's constitution starts to compound. One good skill.md file saves you a little bit of time. A dozen of them start to create a real system. By the time you've documented 100 skills, you've codified your entire operating manual. Jarvis isn't just following prompts anymore. It's executing your personal methodology. The core principle here is that your vault must be navigable by an AI, not just a human. Most note-taking systems are built for human brains. You search, you browse, and you remember where you put things. Jarvis can't do that. It needs explicit structure. Your categories have to be clear, and your tags need to be consistent. Every document should be linked to related ones, and your metadata needs to be easy for a machine to read. This might sound rigid, but it's actually incredibly liberating. Once your knowledge is structured for an AI, it becomes usable by any system you want. You aren't locked into Copilot anymore. You're building your own intellectual infrastructure. The compounding effect works like this. On the first day, your vault has no structure and no memory. Jarvis will struggle. It will ask you a lot of questions and guess at what you want. By the fourth week, you've documented a few core skills. Jarvis still asks questions, but it happens less often because it's starting to anticipate your needs. By the third month, you have 30 skills and clear decision frameworks. Jarvis is referencing your project notes automatically. The system makes better guesses and rarely interrupts you because it understands your constitution. By month 6, everything changes. Jarvis stops feeling like a tool you're trying to teach. It starts feeling like a system that actually knows you. Better structure leads to better reasoning. Better reasoning leads to better decisions. And those decisions compound over time. That's the difference between a simple chatbot and a true operating system. One is designed to forget, the other is designed to learn. Now that we've covered memory, we need to talk about what Jarvis can actually do with all that knowledge. Copilot Co-work, the new execution layer. Memory teaches the system how you work, but memory on its own is just a guidebook sitting on a shelf. It's inert. It doesn't actually do anything until you have a mechanism to bring that memory to life. That mechanism is Copilot Co-work. When Microsoft announced Co-work in March of 2026, it marked a fundamental departure from everything Copilot could do before. This isn't just Copilot drafting an email or summarizing a Word document for you. Instead, Co-work is about orchestrating multi-step work across different applications without waiting for you to copy-paste and manually assemble the final result. There is a distinction here that really matters. Assistance is what Copilot has always done, where you ask, it generates, and then you execute the rest manually. Because you are moving the data yourself, the system has no idea if you actually sent that email or if you just deleted the whole thing. Orchestration works differently. The system plans a sequence of steps, calls the necessary tools, and chains the outcomes together so that each step feeds directly into the next. Because the system is managing the flow, it knows exactly what succeeded and what failed, allowing it to adapt in real time. With Co-work, you describe a goal rather than a specific task. You might say something like, recap our product strategy meeting, draft a follow-up email, create a summary slide, and schedule a check-in for next week. In most organizations, a human would handle this by taking notes, spending an hour writing the recap, opening PowerPoint to design a slide, and then manually checking calendars to send invites. It's a fragmented manual process that is constantly prone to errors. Co-work handles the entire sequence differently. It reads the meeting transcript and drafts the recap, while simultaneously composing the email and deciding which graphics belong on the slide. While it creates those assets, it checks calendar availability and identifies the right attendees based on who actually spoke during the original meeting. It drafts the email, books the meeting, and saves every file to the correct folder. Then it pauses. Co-work isn't fully autonomous, and it shouldn't be. It shows you exactly what it's about to do so you can review, modify, or approve the plan before setting it loose. This is the real shift in how we work because it provides orchestration with human gates rather than total autonomy. The technical engine running this is also a major change from earlier versions. Co-work runs in a dedicated agent runtime, which is essentially a cloud sandbox designed specifically for multi-step execution. It doesn't live on your local machine or sit inside a standard subscription waiting for a prompt. It's a service that receives your goal, breaks it into steps, and evaluates your context from the memory layer. After checking your governance rules from the constitution layer, it plans the sequence and executes only after you hit the decision gates. This is what finally transforms Jarvis from a theoretical idea into an operational system. Memory without execution is just an aspiration, and a constitution without action is just a set of principles. But when you combine memory and constitution with orchestration, you finally have a working operating system. Co-work connects to the Microsoft Graph, which is the unified API that touches everything in your digital workspace. It can read your email, check your calendar, pull documents from SharePoint, and post post updates in Teams. Because it can trigger workflows in Power Automate or write to your OneDrive, it serves as the nervous system of the entire Jarvis architecture. This is where the model moves from thinking to doing. However, Cowork still needs direction to handle situations that aren't perfectly clear. It needs to know how to make decisions when things get ambiguous, and that requires a specific set of rules. Those rules live in agent flows. But Cowork alone isn't enough. You need to teach it your rules. Building skills, the operating system's instruction set. There is a crucial distinction that most people miss, and this is where the architecture moves from theory into actual practice. Prompts are ephemeral. You write them, you get an answer, and then you move on to the next thing. If you need that same result tomorrow, you have to repeat the prompt from memory or go digging through your chat history to find it. Skills are permanent. They live inside your system as versioned, reusable, and discoverable assets. Every time you invoke a skill, you aren't re-instructing the system on how to do a job because you are calling a capability that already knows how to operate. This is the fundamental difference between asking and commanding. When you prompt Copilot, you are essentially negotiating with the system every single time. You have to wonder if it will understand your meaning, prioritize the right details, or remember the constraints you mentioned last week. When you invoke a skill, you aren't asking anymore. You are executing a piece of logic that already encodes your constraints and knows exactly how to succeed in your specific context. Designing a skill requires 3 specific components, starting with the identity. A skill needs a name that describes exactly what it does for your business. Instead of a generic email draft, you might call it the client escalation protocol, or replace meeting summary with executive decision brief. The name matters because it becomes part of your organizational language and changes how you think about your capabilities. When you tell the system to invoke the weekly planning skill, the request is concrete and no longer up for negotiation. Second, you need the specification. This is a clear description of what the skill does, when to use it, and what a successful outcome looks like. This information lives in machine-readable metadata, which is how Jarvis finds the right tool when you ask for help. The description also lists the dependencies of the skill, such as what data it needs and which guardrails apply. This isn't hidden in the background, but is made explicit so you can maintain total transparency and control over the system. Third is the logic. These are the actual instructions that tell Copilot how to execute the sequence. This is where the procedural knowledge lives, including the step-by-step flow, the decision points, and the patterns for handling errors. This is where a skill differs from a standard prompt. While a prompt is just prose, the instructions in a skill are structured with discrete steps and conditions that can chain together. They can even reference other skills or be programmed to fail gracefully if something goes wrong. Take a practical example like managing a complex group of stakeholders. You could build a skill for stakeholder notification after decision that reads a new decision and identifies exactly who needs to be informed. It checks their notification preferences, looks at their calendars for a sync call, and drafts the message in their preferred channel. That is a single skill performing 5 different tasks that would normally require you to jump across multiple systems. Because that skill is now part of your infrastructure, you don't have to remember who prefers email over Teams, because the skill remembers for you. Skills compound over time because each one reduces your total cognitive load. While one skill might save you a few minutes, 10 skills start to save you hours, and 100 skills eventually become your entire operating system. There's also a second compounding effect where skills begin to inform each other. A client escalation skill might call upon the stakeholder notification skill to finish a task. This means you aren't just building isolated tools, but an interconnected system where every new capability makes the others more powerful. This is how Jarvis moves from being a helpful assistant to a transformative force. Skills define what your system is capable of doing, but they don't decide when to do them. To manage those choices and choose between different paths, you need agent flows. Agent flows. Nonlinear reasoning in Power Automate. Everything we have built so far depends on one critical capability. Memory, skills, and Cowork as an execution engine only matter if the system can make nonlinear decisions. It needs to choose different paths based on context, treat exceptions differently than routine cases, and escalate when things get complicated. Without the ability to adapt without a human holding its hand at every step, the system is just a basic script. This is where agent flows enter the architecture. Power Automate is the workflow platform for Microsoft, and for years, these flows have been strictly linear. You define a trigger, an event happens, and then the flow runs a sequence of actions in order. It goes from step 1 to step 2 to step 3, and then it is done. If you want the flow to branch, you have to nest complex conditionals, but the structure is still fundamentally rigid and predictable. Agent flows are different because they are powered by LLM reasoning. They are still built inside Power Automate, but instead of following a rigid sequence, an agent flow uses reasoning to look at the current state and decide what to do next. The conceptual difference is simple. A traditional flow sees an incoming email and performs the same action every single time. It might log the message, assign it to a folder, and send a notification, but the path is predetermined because no thinking is required. An agent flow sees that same email and actually reasons about it. It asks if the sender is a known client, checks the tone for urgency, and determines exactly what type of request it is looking at. Based on all that context, the system decides if the email follows a routine path or if it represents an exception. Routine cases get processed automatically, while exceptions are escalated to a human with the full context provided upfront rather than as an afterthought. This distinction is where Jarvis moves from being a tool to being an operator. In the Jarvis architecture, agent flows act as the decision-making nodes of the nervous system. This is where your constitution is applied in real time, and it is where the system decides whether to act on its own or pause for human judgment. The design pattern stays consistent by focusing on routine versus exception. You define what a routine task looks like in your specific domain, and any request that matches that profile moves through the automated path. Anything that deviates from the norm triggers a different sequence, which might mean gathering more information or seeking a specific set of approvals. Architecture matters here because the system is not making simple binary choices. It evaluates multidimensional criteria like risk levels, stakeholder sensitivity, dollar amounts, and policy conflicts. It synthesizes all these different factors through reasoning to find the right path. That is what the LLM is doing inside an agent flow. It is not just executing a static flowchart, but rather reasoning about what the specific situation requires. This creates a massive advantage by keeping humans in the loop without creating a bottleneck. Humans are only brought in when a situation genuinely requires their judgment, which means routine approvals flow through without stopping. Because exceptions are escalated with the context already analyzed, your team stops reviewing low-value decisions and starts focusing on high-stakes calls. But there is a technical constraint you have to understand. There is a synchronous execution window of about 100 seconds in which the flow must finish its reasoning and return a response. This limit is built into the architecture because cowork needs to know exactly what happened so it can chain the next step in the process. Designing agent flows for Jarvis is not the same as building traditional flows. You cannot do heavy lifting or run expensive computations inside the flow itself, and you definitely cannot wait for minute-long database queries. The flow has to be fast to stay within that window. This means your architectural pattern has to shift toward asynchronous processing. You should have background jobs gathering data, preparing summaries, and pre-calculating what the system might need. When the agent flow finally runs, it is reasoning over pre-cooked information instead of waiting for raw data to be fetched from a slow source. This constraint actually forces you to build a better architecture. It prevents you from creating slow, bloated flows and pushes you toward using modular services and pre-computation. By letting different parts of the system work in parallel, you keep the whole engine moving. In Jarvis, agent flows are where the final decisions get made. Memory provides the rules, skills provide the capabilities, and cowork handles the orchestration. Agent flows are where all three of those layers converge to decide if the system should proceed alone or if it needs a human to step in. This is the mechanism that allows Jarvis to operate instead of just assisting. Now that the execution layers are built, we have to face a hard reality. Nobody actually wants a system that can operate without any limits. Now we're building the nervous system, but it needs guardrails. The governance layer. Why Jarvis needs limits. There is a moment in every organization when someone realizes their AI system did something that nobody authorized it to do. The system might have sent an email that violated a confidentiality agreement, or perhaps it updated records it should never have touched. It could expose sensitive data to people without clearance or trigger a workflow that commits company resources without any approval. In that specific moment, governance stops being a theoretical exercise and becomes a matter of survival. Agency without limits is not a feature, it is a massive vulnerability. You are dealing with a system that can act faster than you can monitor it, and that kind of automation creates immediate liability. This is why the governance layer is not an optional add-on for Jarvis. It is the difference between a system you built and a system that built a reputation your organization now has to own. Governance in Jarvis works at several different levels. The first level is permissions, which defines exactly what data the system can read, what it can modify, and which platforms it can access. These rules are granular rather than vague. Jarvis might be allowed to read emails in your mailbox, but it is strictly blocked from touching your colleagues' messages. It can modify tasks in planner projects marked for automation, but it cannot post in Teams unless you have explicitly designated a channel as automation enabled. These boundaries are not bureaucratic friction, they are structural safety. A system that can read everything and change anything will eventually cause damage, even if it has the best intentions. The second level is policy enforcement. Microsoft 365 already has data loss prevention rules to keep sensitive info from leaving controlled channels, and Jarvis has to respect those rules. Before the system sends an email or shares a document, it checks the DLP policies to ensure the action is allowed. This is not a case of a chatbot asking for permission. The system evaluates whether an action violates a policy before it even attempts to move. If your rules say financial forecasts never leave the department, Jarvis will not draft an email containing that data to an outsider no matter how much sense the request seems to make. The third level is the audit trail. Everything the system does gets logged, including the outcome and the reasoning behind the decision. You need to know why the system decided to escalate a task, what context triggered that choice, and who eventually approved the action. This is about accountability rather than paranoia. When something goes wrong, and eventually something will, you have to be able to reconstruct exactly what happened. You need to see if the issue was a system malfunction, a gap in your policy, or a human judgment call that you now disagree with. Audit trails are the only way to maintain control over a system that operates while you are away from your desk. The fourth level is observability. You have to see what Jarvis is doing in real time instead of just looking at reports after the fact. You need dashboards that show which workflows are running, how many flows are executing every hour, and what percentage of decisions are being escalated. Observability is how you catch a small problem before it turns into a full-blown crisis. The fifth level is the hardest one, which is cultural governance. This is where you set the norms for what the system should and should not do. You have to decide that certain decisions are always human decisions, and you must determine which risks are never worth the efficiency gain. This is an organizational choice rather than a technical control. It needs to be made explicitly, documented in a clear way, and enforced across the board. There is a critical distinction here that most organizations completely miss, which is the difference between trusting the model and trusting the system. Trusting the model means you believe the AI is smart enough to avoid mistakes. You give it broad permissions and assume it will always reason correctly, which leaves you surprised when it inevitably fails. Trusting the system means you assume the model will fail at some point. You build safety into the architecture and design the process so that failures are caught before they cause real damage. You deploy governance because you expect any complex system to eventually operate outside your intended boundaries. The second approach is the only one that actually survives contact with the real world. In Jarvis, governance is baked into the architecture from the very start. It is not an afterthought or a compliance layer that gets bolted on later. It is built into how the system decides, how it acts, and how it accounts for its own behavior. This is what separates a system you built from a system that built a lawsuit. Now that governance is in place, we can talk about the actual foundation of the whole project. Orchestration means nothing without clean access to the systems that hold your information, and that is where Microsoft Graph enters the picture. The data architecture. Microsoft Graph as the backbone. Microsoft Graph is the unified API that touches everything in Microsoft 365. Everything. Your emails live there, along with your calendar events, your Teams conversations, and your SharePoint documents. It holds your OneDrive files, your task lists, and your entire organizational structure. It even manages your meeting recordings, your approvals, and your permission boundaries. Graph is not a database you query directly, but rather an abstraction layer. It acts as a single interface so that instead of learning 17 different APIs for 17 different Microsoft 365 services, you only have to learn one: Graph. This matters for Jarvis because orchestration requires data access, and data access requires a unified interface. You don't want Jarvis hitting Exchange for email, then SharePoint for documents, and then jumping to Teams for conversations. If the system had to learn multiple authentication patterns, error handlers, and rate limit structures for every tool, it would eventually collapse under its own weight. Graph solves that by being the front door where everything flows through a single point of entry. But here's the problem most people don't understand about Graph. It's not unlimited. It is not a tool that scales infinitely, and its specific constraints will force your architectural decisions. The first constraint is throttling. Graph enforces rate limits on how many requests per minute you can send, which depends entirely on the workload and the endpoint. SharePoint has different limits than Teams, and Outlook has different limits than Planner, but the reality is that all of them have a ceiling. When you hit that limit, Graph responds with an HTTP 429 error for too many requests. At that point, you have to back off, wait, and retry with an exponential back-off strategy. This isn't an optional step, but rather how the system protects itself from being overwhelmed. This constraint shapes how you design Jarvis fundamentally. You cannot build a system that queries Graph synchronously on demand for every single decision, or you'll hit those throttle limits within minutes. Cowork will stall, your agent flows will time out, and your users will see nothing but failures. So you design differently by prefetching data and caching what you already know. You batch requests and move the heavy lifting into background jobs rather than real-time flows. By the time an agent flow needs to reason about something, the data is already prepared and summarized, so the system doesn't have to hunt for it. This constraint actually forces good architecture because it prevents you from building slow, bloated systems that depend on expensive operations executing on demand. The second structural reality is security trimming. Graph enforces permissions, which means when Copilot queries for documents in SharePoint, it never retrieves files you aren't authorized to access. When it searches Teams conversations, it won't return messages from channels where you aren't a member, and it respects folder permissions when reading emails. This sounds obvious, but it's actually profound. It means Jarvis inherits your permission boundaries automatically. The system can't accidentally leak data to people who shouldn't see it because Graph refuses to return that data in the first place. Security trimming means you don't need a separate data governance layer because Graph is your governance layer. You configure permissions in Microsoft 365 the way you normally would, and Jarvis respects those boundaries without any extra work. The third consideration is custom connectors. Not all data lives in Microsoft 365, and your CRM might be Salesforce while your ticketing system is Jira. Your knowledge base might be hosted externally, and your financials could be sitting in SAP. Graph alone can't reach those systems, so Jarvis uses custom connectors. These are REST APIs that sit between Graph and your external systems to translate a Graph query into a request the external system understands. The connector retrieves the data and then translates the response back into a format Jarvis expects. Custom connectors are how you extend Jarvis beyond the Microsoft 365 boundary. They allow you to build an operating system that orchestrates across your entire technology stack rather than just Microsoft products. But building custom connectors requires discipline. You need stable APIs, authentication that works at scale, and a deep awareness of rate limits. A poorly designed connector becomes a bottleneck that cripples your entire system. Graph as the backbone means Jarvis has a structured, standardized way to access organizational data. You aren't building custom query logic for every system, and your governance and permissions are baked into the foundation. This allows you to add new data sources without redesigning the entire architecture. This is where Jarvis stops being confined to Microsoft 365 chat experiences and becomes a true operating system that can orchestrate across your entire organization. Graph is the plumbing, but now we need to talk about what actually flows through it. Grounding. Teaching Jarvis your context. Grounding is the mechanism that separates reasoning from hallucination. When Copilot answers a question without access to your data, it's working from training data that is broad but generic. It knows what a CRM is, in theory, and it understands common sales methodologies or how businesses typically structure pipelines. But it doesn't know your pipeline. It doesn't know what a qualified lead means in your specific office, and it doesn't know your typical deal size. When Copilot answers without your data, it invents plausible answers that might be correct by accident, but they are often confidently wrong. This is hallucination. It doesn't happen because the model is broken, but because it's reasoning without any anchor points. Grounding means anchoring reasoning in your actual data. When Jarvis needs to make a decision, it first retrieves relevant information from your systems and then reasons over that specific information instead of generic training data. This changes everything about what the system can do. An ungrounded system might suggest a standard pipeline review process for you to consider, but a grounded system looks at the facts. It sees that your Q3 pipeline has 32 opportunities, with 18 in discovery and 8 stalled in negotiation. It tells you why that's unusual based on your historical patterns and points out exactly what you should investigate first. The difference is the data. The grounded system retrieved information about your actual pipeline, compared it against your history, and provided intelligence specific to your situation. Building grounded reasoning requires deliberate data architecture. First, your data needs to be discoverable. Copilot can't use information it can't find. If your project documentation is scattered across 17 different SharePoint sites with inconsistent naming, Jarvis will struggle to find what it needs. If your customer data is split between 3 different systems with no connection between them, the system will fail to see the full picture. You need structure with categories that make sense to both humans and machines. Predictable naming conventions and metadata that describes what the data represents are essential. While this sounds tedious, it compounds into a competitive advantage because it makes your data usable by any AI system you build. Second, your data needs to be current. Stale data is worse than no data because the system operates with false confidence. Reasoning over outdated information produces decisions that seem reasonable but are built on facts that aren't true anymore. Your customer contact list from 6 months ago or your risk assessments from before new regulations changed everything will lead to bad outcomes. Stale data requires governance. You have to decide what information needs real-time updates and what can be refreshed on a schedule. You must determine the acceptable lateness for information before Jarvis should flag uncertainty rather than treating it as a fact. Third, sensitive data needs clear boundaries. Not everything should be accessible to every grounding query, and financial details might be off-limits for certain decisions. Personal information needs protection and competitive information needs classification so you can decide what Jarvis can see and what's protected from its reasoning. This is where graph connectors matter for external systems. Your CRM and your ticketing system live outside Microsoft 365, and they contain critical context for decision-making. These systems aren't automatically connected to Graph, so you have to bridge that gap. Custom connectors expose your external data through the same Graph interface that already accesses Microsoft 365 data. Now, when Jarvis reasons about whether a customer issue is critical, it can access historical tickets. When it decides whether to escalate a prospect, it can see the full customer history and search your knowledge base for a solution. The compounding effect is profound. One well-organized data source makes Jarvis slightly smarter, but 5 connected sources make the system intelligently aware of context most humans would miss. When you reach 20 connected sources, you've created a reasoning engine that has more context about your business than any individual on your team. But grounding isn't just about having data, it's about being able to use that data without drowning in irrelevant information. When Jarvis needs context about a specific customer, it shouldn't retrieve the entire customer database, but only the information relevant to the current decision. This is where structured search and semantic indexing matter. Your data needs to be indexed in ways that support discovery through semantic understanding rather than just keywords. Finding out why a customer was unhappy last quarter shouldn't require you to manually search through complaint emails. The system should find it because it understands the relationships between the data. This is where Jarvis stops being superficially intelligent and becomes contextually aware. The proactive layer, Jarvis doesn't wait. Everything we have built up to this point follows a very specific, predictable pattern. You ask a question, and the system gives you an answer. You give Copilot a prompt. The system thinks about it. It gives you a response, and then you decide what to do next. You take action, but the system has no idea what happened after that interaction ended. This is what we call reactive architecture. It is the standard way almost every AI system works today. But it is also the exact thing that stops Jarvis from becoming what it needs to be. Proactive architecture flips that model on its head. Instead of waiting, the system watches. It looks for patterns and starts moving before you even think to ask. You are still the one in control, but the system is now the one finding opportunities instead of just responding to things you already noticed. The difference might sound small, but in practice, it changes everything. Most companies use Copilot in a purely reactive way. You finish a meeting with a client, open up Copilot, and ask it to write a follow-up email. It writes the draft, you send it, and the job is done. The problem is that the system did absolutely nothing until you told it to. Jarvis works proactively. When that meeting ends, the system sees the transcript show up in the Microsoft graph. It recognizes that this person is a new prospect in your sales pipeline. It checks your skill.md file and sees that new leads always need a follow-up within 24 hours. Because it knows you are usually too busy to remember these small details, it doesn't wait for your command. It drafts the email, flags it for your review, and sets a reminder so you don't miss the window. You never had to ask because the system saw the pattern and took the first step. The technology that makes this work is different from the prompts or grounding we have talked about so far. This isn't about being smarter, it is about triggers and timing. Graph webhooks are the first part of this trigger system. Whenever something changes in your Microsoft 365 environment, like a new email arriving or a meeting being scheduled, Graph sends a notification to Jarvis. This happens in real time, not minutes later or only when you log in. This creates a completely different way for the system to run. Instead of sitting idle, Jarvis can react to events the moment they happen. If a high-priority email from a major customer hits your inbox, the webhook fires and Jarvis sees it immediately. It checks your rules to see if this needs special handling. If it does, the system drafts a reply and creates a task for you before you even have a chance to open your email client. That is what real proactivity looks like. The system saw something important and it moved first. The second part of this is the heartbeat pattern. You can't rely on webhooks for everything because you don't get a notification when something fails to happen. There is no alert for a task that is simply sitting there overdue or a project that hasn't been updated in 2 weeks. The heartbeat solves this by running jobs on a set schedule. Every hour or every day, Jarvis wakes up and scans your entire workspace. It runs flows that check if anything is moving off track. It looks for stalled projects, missed decisions, or stakeholders who haven't heard from you in a while. The heartbeat is how Jarvis stays aware of your world even when nothing is actively triggering an alert. The result is a system that doesn't force you to manage every single detail yourself. You can stay focused on deep work while the system handles the situational awareness. It finds the gaps and starts the work wherever your rules allow it to act. Of course, this requires very strict governance. Proactive systems can get noisy very fast. If every tiny change causes Jarvis to jump into action, your inbox will be buried under system suggestions that you eventually just start to ignore. To prevent this, the system needs to be smart about which patterns actually matter. Some emails are just noise, and some stalled projects are actually paused on purpose. Jarvis has to learn what is actually worth your limited time and attention. That learning happens through a constant feedback loop. As you interact with the system, it starts to understand your preferences. If you ignore certain suggestions, the system notices and stops making them. If you act on others immediately, it learns to make those a priority. This is the point where proactivity turns into true intelligence. It isn't because the underlying AI got smarter. It is because Jarvis stopped just answering your questions and started predicting what you need before you even realize you need it. Proactivity only works when memory and reasoning are tied together. Multi-agent orchestration, specialized systems working together. A single Jarvis is a powerful tool, but any single agent is going to have its limits. If you have only one agent, that agent has to know everything about every part of your business. It needs to be an expert in scheduling, compliance, finance, and project management all at the same time. The more you try to cram into one brain, the more of a generalist it becomes. We all know that generalists usually make average decisions when they are faced with highly specialized problems. Real companies don't work like that. They are built on specialized knowledge where different teams own different areas. Your finance team doesn't hire people, and your HR team doesn't review technical architecture. Every department has its own logic and its own set of rules. Jarvis needs to be built to reflect that same reality. This is why we use multi-agent orchestration. Instead of one giant agent trying to do it all, you build a network of specialists. Each agent owns one specific domain and understands the tiny nuances and rules that matter in that space. Then you simply connect them. A scheduling agent knows exactly how to handle the logistics of a calendar. It understands different time zones and your specific travel habits. It knows which meetings need a conference room and how to fix a double booking. But that agent shouldn't be deciding if a meeting is actually worth having. That is a business judgment, not a logistics problem. A compliance agent knows all of your legal obligations. It knows which data is allowed to leave the company and who needs to sign off on a specific deal. It knows when an audit is required, but it shouldn't be making business moves on its own. Compliance is a guardrail, not the driver. A communication agent knows your stakeholders and how they like to be reached. It can adjust its tone for different audiences and handle the actual drafting of messages. It knows the how, but it doesn't decide the what or the when. This kind of specialization gives you a massive advantage because each agent stays fast and focused. A scheduling agent that only thinks about calendars will always be better than a generalist trying to check compliance rules at the same time. The whole architecture turns into a clear hierarchy. At the very top, you have an orchestration agent. This agent understands your high-level goals and takes in your requests. It doesn't do the work itself. Instead, it acts like a manager and routes the job to the right specialists. If you tell the system you want to reschedule a team meeting and update everyone, the orchestrator sees that this needs both scheduling and communication. It goes to the scheduling agent first to find a new time. Once it has those options, it passes them to the communication agent to draft the messages. Finally, the orchestrator shows you the whole plan for a quick approval. With one click, the work of two different agents is finished and coordinated. This is what we call delegation in series. One agent finishes its part and hands the result to the next one in line. But sometimes work needs to happen in parallel. If you are doing a project review, you might need 3 specialists to work at the exact same time. The scheduling agent finds a time for the leads, the project agent pulls the data, and the communication agent writes the invites. They all work at once and send their results back to the orchestrator to be combined. Parallel work is much faster, but it is also more complicated to manage. These agents have to coordinate so they don't get in each other's way. They need to share the same context so their final outputs don't clash. The core design principle here is very simple. You should specialize whenever you can and only coordinate when you must. Every agent becomes a master of its own world, but none of them are working in a vacuum. They all live inside the Jarvis architecture. They share the same memory, follow the same rules, and report back through the same system. The end result is an operating system that is far more capable than any single AI could ever be. True intelligence in a complex business isn't about one smart engine. It is about having a team of specialists who know exactly when to work together and when to stay in their lane. This is how Jarvis scales past the limits of a single prompt. Coordination is the key, and that is where Work IQ comes into play. Work IQ, the intelligence layer. Microsoft has been developing Work IQ for years, but most organizations don't actually understand what it is or how it changes everything once you plug it into Jarvis. The common mistake is thinking of organizational data as something static, like an org chart or a directory that lists who reports to whom. While that information is useful for basic tasks, it isn't intelligence because it doesn't reflect how work actually happens. Work IQ is different because it acts as a dynamic graph of how your company really operates. It ignores the theoretical structure in favor of the real one, knowing that Alice might be in marketing, but she spends most of her time collaborating with the product team. It recognizes that while engineering officially manages Project X, the finance team is deeply involved in every single decision because the budget is currently being contested. The system even picks up on the fact that your CEO never reads long memos but will always respond to a short executive summary. This isn't information that a human had to enter into a database. This is intelligence the system learned on its own by observing patterns across your email, Teams chats, calendars, and documents. Work IQ understands relationships in a way a spreadsheet never could. It identifies the actual working relationships, like who people call when a decision needs to be made or who holds the institutional knowledge for a specific system. It knows who has credibility with stakeholders, whose opinions actually shift how others think, and exactly who needs to be in the room before a decision is finalized. It also understands how your documents relate to one another. The system tracks which files belong to which projects and where specific decisions were documented, so it knows which precedents matter for your current situation. It maps how information flows through the office, identifying exactly where knowledge lives and who truly owns it. Timing is another factor the system masters. It learns when decisions typically happen in your business cycle and when certain stakeholders are actually available to talk. Because it monitors these patterns, it knows when to move fast because everyone is aligned and when to slow down because it senses a disagreement is brewing. This is the fundamental difference between knowing a list of facts and actually understanding the context of a situation. A traditional database knows that Alice reports to Bob and Bob reports to Carol, which is a true fact, but it doesn't tell you the real story. It won't tell you that Alice makes most decisions for Project X alone because Bob trusts her, or that Carol cares deeply about the outcome, even though it isn't technically part of her job. WorkIQ knows all of that because it sees the pattern across every single interaction. When Jarvis needs to decide who should handle an approval, it doesn't just look at the formal hierarchy. It queries WorkIQ to understand the actual decision-making reality, routing tasks to the people who will actually get them done, rather than just the people with the right titles. Jarvis also uses this intelligence to prioritize what needs your attention. It understands which issues will ripple through the entire company and which ones will stay contained within a single team. A change in the sales process affects everyone, while a change in a weekly stand-up is local, and WorkIQ helps the system understand that scope of impact. When you need context quickly, Jarvis uses WorkIQ to find the real experts. It doesn't look at job titles, but instead looks at observed expertise to find the person who understands customer pain points better than anyone else. Even if someone has officially moved on to a different department, the system remembers they have the deep context you need right now. This completely changes how Jarvis handles routing, escalation, and prioritization. Decisions flow to the people who can actually make them, and information reaches the people who truly understand it. The result is a system that operates based on how your organization actually functions, rather than how the org chart says you should work. With WorkIQ backing the system, we can finally look at how to actually build this in the real world. The build, architecture, and practice. Understanding the architecture in theory is a good start, but building it for real is a completely different challenge. I want to walk you through how this actually happens step by step in a real organization, because theory is useless if you can't execute the plan. The build always starts with the memory layer. Even though memory isn't the most powerful part of the system, it is the foundation that everything else depends on to function. You start by structuring your vault, but you don't need to make it perfect right away. Start rough and refine it as you go, creating folders for projects, clients, and research that map to your actual daily work. Don't try to design the perfect filing system upfront because you'll probably get it wrong, so just build what makes sense now and reorganize as you see patterns emerge. Next, you need to document your skill. MD files. Focus on the processes that cause the most friction, like the things you do repeatedly but always have to re-explain to others. These are the workflows where you spend way too much time on setup, so write down the concrete steps and decision points rather than just a vague description. You need about 5 to 10 core skills before the system starts to show its value. Having 5 skills means Jarvis can handle 5 major workflows without you stepping in, and once you hit 10, you've usually covered most of your daily routine. By the time you reach 50 or 100 skills, you have essentially turned your entire operating manual into code. This phase is going to take weeks instead of days. You will write a skill, test it, and then realize you left out a constraint or misunderstood how a decision is actually made. You have to iterate. After that, you move to the action layer by setting up Copilot Cowork. Don't try to automate everything at once, but instead pick the one high-value workflow that would save you the most time if it ran perfectly. Maybe that's your weekly planning rhythm or how you handle client recaps, but whatever it is, pick just one. Map that specific workflow to Cowork by identifying every step in every system that needs to be touched. You need to know where the decisions happen and where the system needs to stop, and wait for your human judgment. Build Cowork to handle that one workflow from start to finish, then test it and iterate until it is completely reliable. Then you can add agent flows. This is where you teach Jarvis when it should escalate a problem and when it should keep going. Define what a routine task looks like, setting clear conditions for what can be handled automatically and what needs to be flagged for your review. Now it's time to connect your data. Your CRM might not be in Microsoft 365, and your knowledge base might live on a completely different platform. Use graph connectors to bring all that information into one interface, but don't try to link every single system at once. Only connect the ones that matter for your first few workflows and add the rest as you expand. Testing against your actual history is the most critical step. Don't use hypothetical scenarios, but instead look back at the last 3 months of real work and pull out 100 examples for Jarvis to handle. Run the system against those old cases to see if it makes the same decisions you did or if it misses important edge cases. You are going to find gaps in the system. You'll realize your skill definitions weren't quite finished or that your agent flow didn't account for a specific situation. This is the time to fix the skill, update the flow, and run the test again. You should only move to the next workflow after Jarvis handles the first one perfectly every single time. This is the part of the process that people usually skip when they talk about AI. You don't just flip a switch and watch Jarvis come to life, because you have to build it incrementally, one skill and one workflow at a time. The best part of this approach is that if something breaks, it only breaks one specific workflow instead of your entire operation. You can find the bug, fix it locally, and then continue expanding your system. By the 3rd month, you should have 3 or 4 workflows running smoothly on Jarvis. By month 6, you'll have a dozen, and by the end of the year, you will have covered your entire operational routine. Every time you iterate, the system learns more about how you work. Every test you run uncovers a gap you didn't know was there, and every refinement makes the whole system more reliable. This is the only way to move from a theoretical idea to a fully operational system. The architecture is the plan, but the implementation is where the real work happens. Avoiding the trap. Why most Copilot builds fail. I've watched enough Jarvis-style projects fall apart to see the patterns, and they aren't the ones you'd expect. The first failure mode sounds counterintuitive, but it's the most common one I see. Organizations treat Jarvis as a feature to deploy rather than a system to build. But here's the problem. A feature has a completion date where you scope it, build it, ship it, and move on. A system is different because it requires ongoing operation, constant maintenance, and governance that evolves as it hits reality. When you approach Jarvis like a feature, maybe by saying, let's implement Copilot for approvals by June, you're underestimating the work. You aren't budgeting for the iteration needed when agent flows hit edge cases, and you aren't planning for the skill updates required when your processes change. Most importantly, you aren't staffing for monitoring after the launch. 6 months later, you have a tool that works in perfect scenarios, but breaks in production the moment reality intrudes. You'll probably blame the technology, but the flaw isn't the AI. It's that you built infrastructure without planning for operations. The second failure mode is underestimating governance. It's not that organizations don't know they need it, but they treat it as an architectural afterthought. They treat governance like compliance theater or a simple checkbox. They assume that because they have data loss policies, they're governed. Then Jarvis hits a scenario those policies never saw coming, and the system acts in ways nobody authorized. Suddenly, governance becomes an emergency. This happens because governance isn't something you can just bolt onto a system after it's already built. It has to be baked into the architecture from the very first day because it shapes every decision the system makes. And if you build the AI first and add the rules second, you'll spend months retrofitting controls into a design that wasn't meant for them. You'll end up constraining the system so much that its power disappears. It's better to build governance into the foundation, even if that means your initial deployment feels a bit slower. The third failure mode is context overload. Organizations look at the potential of the memory layer and decide to give Jarvis access to everything. They feed it every email, every document, every meeting transcript, and every customer record they own. There is a broken assumption here that more context always leads to better decisions. In reality, it doesn't. At a certain point, more context just becomes noise that the system has to sift through to find what actually matters. That extra data slows down decisions and increases the risk of hallucinations. It also makes the system nearly impossible to debug when it fails because there is too much context to trace where a bad decision started. The winning approach is the opposite. Give Jarvis only what it needs for specific decisions by starting narrow and expanding deliberately. Quality of context will always matter more than quantity. The fourth failure mode is measurement theater. Most organizations don't actually track what matters, and instead they measure what's easy. They look at how many times Jarvis ran or how many workflows finished, but none of those numbers tell you if the system is actually working. The real value is hidden in the details. You should be looking at exception rates to see if more decisions are being escalated than before. If they are, the system might be too conservative, or it might be catching real errors that humans used to miss. You need to look at processing time to see if Jarvis is actually making things faster or just adding latency. Most importantly, you need to measure user trust. Do your team members believe in the decisions, or are they ignoring the AI because they don't think it understands their world? Organizations that fail are the ones tracking activity instead of outcomes. They measure volume, but they don't measure value. The fifth failure mode is building only for the happy path. You design your agent flows, assuming the customer's credit is fine, the info is in the system, and the approvers are all at their desks. Those perfect scenarios might cover 80% of your cases, but the other 20% are where your system succeeds or fails. The organizations that struggle are the ones that didn't plan for failure. They never asked what happens when information is missing or when two policies conflict. They built for the normal cases and let the difficult ones break the machine. Jarvis succeeds because it was built around exceptions, not routine operations. The governance layer isn't there to enforce rules on easy cases. It's there to handle the moments where rules clash. Build for the exceptions first, and the happy path will take care of itself. The adoption pattern. Rolling out Jarvis. Deployment and adoption are not the same thing. You can deploy Jarvis to your servers tomorrow, but you cannot deploy trust. Trust is something that has to be earned over time. This is why adoption patterns matter more than your deployment timeline. A system pushed onto skeptical users is a system that nobody will ever use. However, a system rolled out slowly with constant refinement becomes infrastructure that people actually depend on. The pattern starts with constraint. This isn't about limiting the AI, but about focusing it. You don't try to change your entire company at once. Instead, you pick one high-friction process that wastes the most time. You look for the one that frustrates people because it's repetitive but unpredictable, or the one where decisions always seem to take longer than they should. This might be your lead qualification, your project intake, or your incident triage. You want to pick the specific spot where you'd see immediate value if Jarvis could handle the routine cases on its own. Once you have that, you have to map what actually happens, not what the handbook says should happen. This is where the model usually breaks. Most organizations map an ideal process that management believes is true, only to realize the real world is completely different. Actual work is full of workarounds and informal decision points that never made it into the documentation. There are gatekeepers who hold power without a title and exceptions that happen so often they've become the standard. You need to find these realities before you ever start building. Sit with the people doing the work and watch them make choices. Ask them why they took one path over another and document every edge case they mention. The formal manual is just one input, but the messy, actual process is what you really need to teach Jarvis. After that, you build a prototype using historical data. Go back a year and pull 200 examples of real decisions made in that process. Run Jarvis against those old cases to see if it makes the same calls a human did. You'll find gaps and realize your logic didn't account for certain conditions, but that's the whole point. You're discovering reality in a safe environment instead of finding out in production where mistakes actually hurt your customers. Now you have to measure the outcomes. Don't just look at how many cases Jarvis handled. Look at the exception rate to see what percentage of decisions the AI is making alone versus how many it's sending to a human. That number should move toward your goal over time, but it should never be 100%. Some escalation is healthy because some decisions will always require human judgment. You also need to watch the processing time. If Jarvis is adding delay because your team is second-guessing every recommendation, then the system is failing even if the math is right. You need both speed and trust to succeed. If you only have one, you're just performing theater. Finally, look at user satisfaction. Do the people in the process actually believe Jarvis is making sound judgments? They don't need it to be perfect, but they do need to see it as a reliable starting point. Trust shows up in how people behave, not in how they answer a survey. Iterate on every single cycle. Look at the cases where Jarvis escalated when it shouldn't have, or where it moved forward when it should have flagged a problem. Refine your logic, update your skill. MD files and adjust the grounding. Each of these cycles should reduce unnecessary noise and increase the number of confident autonomous decisions. Run this tight loop for 6 weeks. That's enough time for your team to learn how to work with the system and build real confidence. Once they see that the AI's decisions generally make sense, you've won. Now you're ready to move to the next workflow. This is how adoption compounds. You don't transform everything at once. You prove value in one spot, earn the trust, and then expand. Adoption is about trust. So let's talk about how we actually built that. The trust problem. Why users don't believe in Jarvis. There is a specific moment that happens in every organization where Jarvis makes a decision that looks perfectly reasonable on paper, but then a human steps in and realizes the system missed the entire context. Maybe a customer complaint gets escalated to the retention team when it actually needed a simple fix from operations. You might see a project flagged as high risk based on generic criteria that don't actually match how your company handles risk. Or perhaps a decision just moves forward autonomously when it really should have paused for a human to take a look. In that exact moment, the trust breaks. And once that trust is gone, it takes months of perfect performance to build it back up. The problem here isn't that Jarvis made a massive catastrophic error. The problem is that Jarvis couldn't explain why it did what it did. The system can't tell you that it routed a ticket based on sentiment analysis or historical patterns that suggest retention involvement leads to faster resolutions. It just shows you the outcome. There is no working shown and no visible reasoning. From the perspective of the user, a decision just appeared out of nowhere. This is the core of the trust problem. It isn't that Jarvis fails sometimes, because every system fails eventually. The real issue is that when it does fail, you have no way of understanding the logic behind the mistake. Transparency is the only way to fix this, but real transparency requires much more than just keeping a log of what happened. The system has to show its work by making the factors that influence the decision visible to the people using it. It needs to articulate its reasoning in terms a human can actually understand. Jarvis needs to be able to explain the data it considered and the specific policies that shaped its recommendation. It should be able to point to the precedents that informed its judgment while being honest about where it feels confident and where it feels uncertain. This kind of transparency doesn't actually require high-level technical breakthroughs. It just requires you to be intentional about the design. Every agent flow you build needs to be designed to explain its journey, not just reach a destination. Some of these explanations are going to be very simple. An email arrives, the sentiment analysis detects frustration, and the customer history shows 3 previous complaints, so the system escalates the issue to retention. That logic is easy to follow. Even if you don't agree with the move, you can at least see the path the system took to get there. Other decisions are much more complex. A project might look high risk because of a dozen different signals like budget variance, timeline slips, and low stakeholder satisfaction scores. Jarvis weighs all of these factors against your governance rules to surface a risk assessment, but you have no idea which signal carried the most weight. You can't tell if the project is actually in danger or if Jarvis is just being way too cautious. Without the system breaking down that reasoning, you're just guessing. This is where explainability stops being a theory and starts being a part of your daily operations. You need the ability to actually argue with Jarvis. You should be able to tell the system that while the timeline slipped, that slip was an intentional choice because you added scope to the project. That isn't a risk indicator. It's a change order. When you do that, Jarvis learns that scope additions shouldn't trigger a red flag. The system gets smarter because you provided the context it was missing. This requires a human-in-the-loop architecture. You shouldn't view this as a limitation or a sign that the AI isn't ready. It is a core feature. This is the mechanism that allows a system operating in your absence to learn the specific nuances of your actual business environment. A lot of organizations see human intervention as a failure state. They think they wanted full autonomy, but had to settle for human review because the tech wasn't good enough. That is a total misunderstanding of how these systems work. Human feedback is the only thing that prevents an automated system from drifting away from your original intent. If you don't have that feedback loop, Jarvis will just follow the rules you wrote on day one forever. It won't care if your business changes or if new situations emerge that the original rules didn't cover. Without a human in the loop, the system will slowly become more and more disconnected from reality every single day. When you include human feedback, every single correction becomes a new data point. You are feeding the system information about how your business actually functions compared to how you thought it functioned when you first built the workflow. Over several months, this feedback reshapes Jarvis into something better. It stops being a rigid engine and starts becoming an adaptive reasoner that understands the patterns of your specific world. This is the fundamental difference between being autonomous and being accountable. An autonomous system makes a choice without you, which sounds great until something breaks and nobody can explain why. An accountable system makes a choice, shows you the logic, takes your feedback, and then uses that feedback to make better choices in the future. It might feel slower at first, but it is much more trustworthy because you never lose visibility or control. Trust only happens when three things are true. The system explains itself, you have a way to correct it, and you can see it learning from those corrections. When you have all three, people stop looking at Jarvis as a mysterious black box. They start seeing it as a tool they finally understand and know how to steer. Trust leads to adoption. Adoption reveals what needs to improve. The compounding effect, why this matters over time. The real power of a system like Jarvis doesn't show up on the first day. It's something that accumulates. When you first start, Jarvis is just another tool. You've built one single workflow to handle something like email triage or project intake. It works well enough and it probably saves you a few hours of work every week. That is a nice productivity boost, but it isn't going to transform your entire company. At this stage, Jarvis is just a small multiplier on one specific process. By the time you hit the 1 month mark, the vibe starts to shift. The system has processed hundreds of decisions and seen plenty of edge cases. It has been corrected on its mistakes, and the memory layer has started to soak up context about how your organization actually runs. Your agent flows have been polished based on real-world feedback. Jarvis isn't a generic tool anymore. It's becoming an operating system that is custom fit to your environment. You've probably added a second or third workflow by now, and the system is starting to manage your entire weekly planning rhythm. It is handling stakeholder communication and catching small details that a human would usually miss. Jarvis has officially become a system. It isn't just saving you time anymore. It is actively reducing errors and making your decisions better because it has access to more information than any single person. Once you reach the end of the first quarter, that compounding effect really starts to accelerate. Jarvis has been running for 12 weeks straight. It has accumulated months of learned behavior and handled situations you never even planned for. Your governance layer is mature, and your agents are working together in predictable patterns. Because you've connected more of your external systems, the grounding is much deeper. Now, the system isn't just running individual tasks, it is orchestrating work across different workflows. When a schedule changes, Jarvis knows exactly which stakeholders need to be notified. When a new compliance rule pops up, Jarvis pushes that constraint through every affected workflow without you having to lift a finger. At this point, Jarvis is the infrastructure that makes work happen. People start consulting the system before they make a move because it consistently has better information than they do. By the time you reach 1 year, the gap between companies using Jarvis and companies that aren't becomes a structural divide. The organizations without Jarvis are still operating on patterns they came up with years ago. Someone designed a process, wrote it down, and maybe tweaked it once or twice. But the core structure never changes because changing it requires a human to stop what they're doing and drive that change manually. It is a slow process that is constantly piling up technical debt. People eventually start creating workarounds for the rigid rules, and those workarounds turn into a mess of hidden complexity. New hires never actually learn the official way of doing things because everyone knows the real process is different. Organizations running Jarvis are in a completely different league. Their system is learning every single hour of every single day. Every decision feeds back into the intelligence layer, and every correction makes the next decision more accurate. Every new workflow you connect makes every existing workflow smarter. The system doesn't get worse over time. It gets better. It compounds and it accelerates. The gap between these two types of companies widens because organizational inertia is linear, but the compounding effect of AI is exponential. Month 2 is a little better than month 1, but month 12 is light years ahead of month 11. By the second year, the company is almost unrecognizable because the system has moved from just helping with work to being the very foundation where work occurs. This is exactly why timing is so important. A company that starts building Jarvis in 2026 is going to have a competitive advantage that a company starting in 2028 simply cannot catch. You can't just buy your way out of that gap because the compounding effect doesn't reset. It builds on everything that came before it. If you start late, you don't get any of that historical learning. You start at zero while your competitors have a full year of accumulated intelligence baked into their operations. The gap grows exponentially. And that isn't just a guess. It is basic structural mathematics. The earlier you start, the wider your moat becomes. The real cost. Engineering, not just licensing. Most Jarvis projects break before they even start because the cost conversation happens the wrong way. You run the numbers and see that Copilot Pro costs $20 a month, so you multiply that by your team size and decide it looks reasonable enough to get approved. It goes into the budget under software subscriptions, and you think the job is done. But 6 months later, you have spent $100,000 on engineering that never appeared in your original cost model. You are paying for custom connector development, agent flow testing, and memory layer curation, while also trying to fund skill definitions and data architecture. This includes observability infrastructure and governance cycles that nobody planned for, proving that the licensing was never the real hurdle. The engineering cost was the invisible wall you didn't see coming. This is the honest conversation you need to have before you start building. First, you have to account for architect costs. You cannot build a system like this with prompt engineers because you need people who understand systems thinking and can map out your actual business processes. These experts must understand Microsoft Graph and Copilot Studio deeply enough to make design decisions that won't turn into technical debt in 6 months. Because these people are scarce and expensive, they often cost 2 or 3 times what a general developer makes. You will need them for at least the first year, so you should budget conservatively and assume you need 1 or 2 full-time systems architects depending on your size. Second, you have to build the data governance infrastructure. Your data is currently scattered across finance, operations, and sales systems, while your knowledge lives in 17 different SharePoint sites with inconsistent naming. Before Jarvis can operate with any reliability, that chaos needs a structure, which means someone has to audit what exists and design a coherent information architecture. This is a 6 to 12 month engagement for a dedicated person who oversees the cleanup and migration work. Most organizations ignore this cost because they think of it as simple data hygiene, but in reality, it is the foundation for everything the system does. Third, you must plan for ongoing maintenance and iteration. The model will improve, Microsoft will release new features, and your own business processes will evolve over time. You cannot simply build the system and launch it without a team to keep it running. You need continuous engineering capacity that is meaningful, even if it isn't full-time. I recommend budgeting for at least one half-time engineer who is permanently allocated to Jarvis operations to own the monitoring and feedback loops. This person keeps the iteration cycles moving so the system stays aligned with your daily reality. Fourth, there is the hidden cost of iteration itself. You will eventually discover that your flow logic doesn't handle edge cases, or you might realize a data source doesn't provide information in the format the system expects. These aren't failures, but they are the normal parts of building complex systems that require rework and refinement. You should budget for this explicitly by assuming your initial implementation will need 3 major iteration cycles before it reaches production stability. Each of these cycles will cost you weeks of engineering time that you need to account for upfront. Now we have to talk about the ROI conversation, which is where most organizations start to fool themselves. They try to measure time saved by looking at approvals that used to take 20 minutes and now take 5. They multiply that by the number of approvals and the salary of the person doing the work to claim they are saving $40,000 a year. But that isn't the real ROI. The real value is that the person freed from that busy work is now doing strategic work they never had time for before. A procurement manager who stops chasing signatures and starts focusing on vendor strategy might save the company hundreds of thousands in negotiated contracts. The unmeasurable ROI almost always dwarfs the time savings you can put on a spreadsheet. Instead of looking at minutes, you need to ask if Jarvis reduces your decision cycle time or if your decisions are actually improving in quality. You should track whether risks are being caught earlier and if your stakeholders are making better informed choices than they were last year. These questions don't have immediate dollar values attached, but they determine if the system is actually improving your operations or just automating your mess. Budget for Jarvis like you would for any other infrastructure by expecting high engineering costs and measuring value through improved outcomes. That is the only honest way to look at the cost. Cost is real, so is the alternative. What happens if you don't build this? The real question isn't whether Jarvis matters, but whether your organization can actually afford to ignore it. Let's look at what happens inside a company that chooses to wait while their competitor starts building in early 2026. By year 2, that competitor has approval workflows that run autonomously and a team that spends 40% less time on status updates. Their system maintains continuous situational awareness, which allows their executives to make decisions based on real-time context instead of reports that were compiled yesterday. They catch risks before they turn into crises because their infrastructure is designed to surface problems automatically. Your organization, meanwhile, is still operating the way you always have. You are stuck in email threads where context disappears, and you keep holding meetings where the same information is re-explained because nobody has access to a shared knowledge base. Your approval processes move only as fast as the slowest human in the chain, and your decisions are made with incomplete data because nobody has time to find it. On day one, this doesn't feel dramatic because the gap is small and your processes still move. You aren't broken yet, but you are operating with less visibility and slower execution than the person across the street. By year two, that gap becomes a structural problem you can't easily fix. Your competitor's team now operates differently because they consult Jarvis before making moves, not because they have to, but because the system surfaces information they didn't know existed. They move faster because they aren't waiting on human approval chains for routine cases, and their planning cycles have become entirely data-driven. Their retrospectives generate insights automatically, and their compliance is stronger because governance is enforced every second instead of being audited once a quarter. They have replaced manual labor with a system that learns. Your team is still doing things the old way because changing your operations requires an intentional effort that nobody has time for while you're busy executing. Your processes might be slightly better than they were last year, but those improvements came from hiring more people rather than building better structures. You are trying to solve modern problems with more labor while your competitor is solving them with better systems. This creates a massive disadvantage when you realize you are paying for headcount to do what their software does for free. Now look at what this means for your place in the market. Your competitor launches new products faster because they can gather stakeholder feedback in a fraction of the time. They don't need as many meetings to reach a consensus because the context flows exactly where it needs to go without human intervention. They identify opportunities earlier and move capital more efficiently because their approvals don't languish in a digital queue for weeks. This allows them to attract better talent because the work feels less bureaucratic and more focused on strategy and creation. You are left trying to compete using organizational structures that were built for a much slower era. You might have more people, but you have less efficiency and worse decisions despite having more meetings and more email. The labor you added to help you scale has now become a permanent cost disadvantage that makes it impossible to match your competitors' margins. The gap doesn't widen through a single dramatic failure, but through the slow accumulation of disadvantage that happens when your rival improves exponentially while you improve linearly. By 2027, building this system stops being a competitive advantage and simply becomes the cost of doing business. New companies entering your market won't even consider the old way of working because they will see that the winners all operate through intelligent systems. They will deploy Jarvis architectures from day one, and the question for you won't be whether you should build it, but how far behind you are. You can try to catch up in 2028, but you will be starting from zero while your competitors have years of learned behavior and smarter data. The real cost of waiting isn't just the money you lose, but the organizational capability you never develop. The gap grows every day you spend debating the budget, and the compounding effect of these systems waits for no one. The time to build is now, because the organizations that move first will own the structure that everyone else will be struggling to copy for the next decade. The next layer where Jarvis goes from here. Everything we have discussed so far is just version 1. It is a foundation, a starting point. But the frontier of what is possible goes much further than the basics of a single system. The first shift is specialization. You start by building a general Jarvis to handle your daily operations, but the real power comes when you tune a second instance for your specific industry. Imagine a healthcare Jarvis that actually understands clinical workflows and patient data protocols instead of just processing text. Think about a financial services version that natively understands risk models and trading compliance, or a manufacturing system that tracks supply chain dynamics and production schedules in real time. These are not separate, disconnected tools. They are different versions of the same architecture, trained on specific skills and grounded in the rules of your industry. When a healthcare company deploys this, a new hire can use it immediately because the system speaks the language of clinical practice. This is not just a cool feature. It is a structural advantage that changes how you compete. The next layer is organizational scale. Up until now, we have looked at Jarvis as a system for an individual or a small team. But the real shift happens when you build a multi-tenant Jarvis that serves your entire company. Different departments, different regions, different business units, all of them operating through one unified intelligence layer. Now, you might think this would create total chaos. You might worry about people stepping on each other's decisions or seeing data they shouldn't. But that only happens if your architecture is weak. A solid governance layer ensures that each unit only sees what they are authorized to handle. The orchestration layer allows specialist agents to own their domains, while a master controller keeps everything in sync. It is a federation of specialized systems that share the same infrastructure and the same learning. The advantage here is massive. When your sales team discovers a process that works, that learning spreads to the rest of the company automatically. If operations builds a skill that saves time, every other department can adopt it instantly. Your best practices no longer spread through slow meetings or emails. They spread through the infrastructure itself. Companies that work this way do not just beat their competitors, they outperform their own past results. Beyond scaling across teams comes the challenge of cross-system orchestration. Right now, Jarvis mostly lives inside Microsoft 365, but your business data is scattered. It is in Salesforce. It is in your ERP. It is in your customer support platform. From the perspective of Jarvis, these systems are silos. They are powerful, but they are isolated from each other. The next layer breaks those walls down for good. Jarvis begins to coordinate across all these systems at the same time. A decision that involves your CRM, your accounting software, and your operations no longer requires 3 separate processes. It flows through Jarvis as one unified action. You get one data model and one reasoning layer. The result is a decision that accounts for the complexity of the whole company instead of just fixing a problem in one corner. Then we move into predictive behavior. Today, Jarvis is reactive. Something changes, the system sees it, and then it responds. That is helpful, but the frontier is anticipation. Jarvis should not wait for a signal to appear. It should forecast what is likely to happen by looking at patterns. It should find opportunities before they are obvious and flag risks before they turn into a crisis. This is not science fiction. It is just pattern recognition at a massive scale. Once your Jarvis has processed 2 years of your company data, it knows what a normal day looks like. When something starts to drift, the system sees it as a signal rather than an anomaly. If a contract usually closes in 10 days, but this one is taking 20, the system notices. It tells you to probe deeper or follow up. The system is not creating more busy work. It is seeing the patterns that humans miss because we cannot hold 2 years of data in our heads at once. The final frontier is the self-improving system. We already know Jarvis learns from your feedback, but the next step is Jarvis learning from its own mistakes without waiting for a human to point them out. The system could run simulations of its own decisions in a sandbox environment to see what happens. It could evaluate those outcomes and refine its own logic. This is where the system stops being a tool you use and starts being infrastructure that operates. It becomes less dependent on constant human oversight and more autonomous in how it learns. This is not about making the system dangerous. Your governance still applies. It is about letting the system get smarter without needing an engineer to step in every time. These layers do not all arrive on the same day. You start with the foundation. Then you specialize. Then you scale it across the company and move beyond Microsoft 365. Finally, you add predictive power and self-improvement. Each step might take months or even years, but each layer is a logical extension of the one you built before it. This is the path for any organization that is serious about building intelligent infrastructure. What you need to do Monday morning: stop planning and start building. Pick one single process in your business. Map out how the decisions in that process actually get made. Build your memory layer around that specific workflow. Test Jarvis on your old cases to see how it handles them. Measure the results and then iterate. That is the only way to start. Subscribe to this channel to stay updated on how this is evolving. The landscape is shifting every single month now. Connect with me on LinkedIn because I want to see what you are building. The companies that move first are the ones that will define how everyone else operates. The only real difference between a basic chatbot and a true Jarvis is the architecture. Now you finally have the blueprint.